Geometry, we have ourselves a low budget film this week for YouTube. The lesson this week is on writing equations of lines. This should be related to what we did last week, but slightly different. Let's remind ourselves from what we had learned once upon a time, maybe forgotten, but we wish to remember. Point slope form equation of a line is y minus y1 equals m times x minus x1. We call that equation of a line that contains, since it's called point slope form, it's the equation of a line that contains the point x1, y1. So numbers are given for x1 and y1. Variables remain x and y in the finished result. And the line has slope m. Notice m will go in front of the parentheses containing the x when we're in point slope form. The slope of a line containing points, two different points, let's say. Say the points are called x1, y1 and x2, y2. That slope of the line that contains those 2 points can be found by a formula we should be familiar with, which is m equals y2 minus y1 over x2 minus x1. The y's are on top, the x's are on bottom. Notice that the x1, y1 pair are on top, y's on top of x, and the x2, y2 pair, the y2 is on top of the x2. Keep those orders straight. The next thing we wish to do is to review that form equation for lines that are in slope-intercept form. I might have misspoke. Lines whose equations are given in slope-intercept form are of the form y equals mx plus b. We call that equation of a line with slope m, that's in front of x, and the y-intercept b, which is here, but as points plotted or labeled on a y-axis, we give those as ordered pairs, so in this case 0, b. Let's go to some examples. We're going to write the equation of the line in slope-intercept form that has a slope and point given. This is very similar to the directions that you'll read for some of your problems. So in this example, the slope given is negative 2/3. The point given is the ordered pair 6, 1. The x-coordinate is 6, the y-coordinate is 1. So I'm reinforcing the slope-intercept form by indicating that the m is negative 2/3 and a given point is 6, 1. They're given. Now we wish to finish the problem because the direction said so in the form that's called slope-intercept form. So I remind ourselves this is the target form right here, slope-intercept, y equals mx plus b. We can start with slope-intercept form or we can start with point slope form. It doesn't matter which form we start with, but we've got to finish this problem in slope-intercept form, which is y equals mx plus b. To do method 1, we'll start and stay in slope-intercept form, that is y equals mx plus b. So we have to use the given point, 6, 1, and the given slope, negative 2/3, in the form y equals mx plus b. So the y we have is 1. There's the 1 for the y, equals the given slope, m, is negative 2/3. So for a set of parentheses where m used to be, I substitute the value negative 2/3 times the x that goes with the y value 1. That x is 6. Thus, a set of parentheses for where x used to be, we now have parentheses with the number 6 in its place. And then plus b, which we need to find. If you take a look at this arithmetic, 3 will go into 6 twice, and then 2 times negative 2 is negative 4. That's where this negative 4 came from. The 1 equals remains 1 equals. The plus b remains plus b. To finish this problem solving for b, we add 4 to both sides. Well, 1 plus 4 is 5. 4 add negative 4 is 0, and 0 plus b is b. So adding 4 to both sides gives me b equals 5. And so y equals the given slope, negative 2/3 times x, plus the b we just found, 5, is it. That's our slope-intercept form for this problem that we were asked to find. Same problem. This time, though, I'm going to start with point slope form. I'm calling this method 2. So I'm going to start with point slope form. So I'll remind you that the slope given for what we're working with is negative 2/3. The point given was 6, 1. This time, the y-coordinate, y1, the x-coordinate, x1, will go in for where we have these dummy variables, these subscripted letters here. So the y-coordinate given 1 goes for y1, and y minus remains part of the point slope form. Equals, the slope m is negative 2/3, so I removed the dummy m, replaced it with a set of parentheses, and plugged in the given slope, negative 2/3. Times, parentheses, x minus the x-coordinate that went with the y-coordinate 1, that's 6. Now I'm going to distribute on the right side. The left side for now remains y minus 1 without the parentheses around the 1, equals negative 2/3 distribute somewhere over the rainbow. Negative 2/3 x here. Negative 2/3 times negative 6, or subtract 6, is like negative times negative, so we know that's positive. The bottom number 3 can cancel the integer 6 by dividing 3 into 6 twice. Get the result 2 times the numerator 2, and that's where this 4 came from. Some of you will treat 6 as 6 over 1, and do 2 times 6 is 12, 3 times 1 is 3, and 12/3 is 4. You get there, you just get there a little bit slower. Then from this form, I add 1 to both sides. Add 1 to minus 1, it goes away, and you're left with y equals. The negative 2/3 x remains itself. Adding 1 to 4 gives me 5. Notice that's the same result that we found when we started with point slope form. It was supposed to be the same. Now what we're going to do is a different type problem. They will still give you information as in the previous problem. We still have a slope and a point, but now they're asking me to find a line that is parallel to the given line, y equals negative 2/3 x plus 5. Not only is it going to be parallel, but I'm also going to give that it's going to pass through a point, namely 3, 0. Keep in mind that parallel lines have equal slopes. They have the same slope, but they have to have different y-intercepts to be parallel. Different y-intercepts. So again, I start with the I start with slope-intercept form this time. Y equals negative 2/3 x plus b, using b because the one I'm chasing down I know should not have y-intercept 5. So I'm going to start with the fact that I'm going through a different point now than the original line. See, the one parallel to this one is going to pass through this point. So I'm going to use this point using slope-intercept form. That's my y, that's my x. So there's the y, 0. See where y used to be? I have 0. Equals, same slope, because they're parallel, negative 2/3, parentheses around the x that went with the y value 0. That was 3. And that's why 3's in here where x used to be. These 3's cancel. This is going to become 0 equals negative 2 plus b. 0 equals negative 2 plus b. Add 2 to both sides and you get 2 equals b, which is the same as b equals 2. So the line we were looking for, parallel to this given line, whose equation is y equals negative 2/3 x plus 5, and the one we're looking for, which passes through the point 3, 0, that line has this equation, y equals negative 2/3 x plus 2, based upon the work we did here. Notice they do have the same slope. They both have negative 2/3 as their slope, but different y-intercepts, 5 versus 2. So yep, they're going to be parallel. Now we want to find a line perpendicular. Perpendicular, that's my symbol for perpendicular. A line perpendicular to the given line whose equation is y equals negative 2/3 x plus 5. And the line I'm looking for that's going to be perpendicular to this one, it's going to contain the point for negative 1. That means the equation I'm going after, if I graphed it, it would be a line perpendicular to this one, and it would contain or pass through the point 4, -1. You must remember that perpendicular lines have slopes that are negative reciprocals. Negative reciprocals. So the line equation I want to be perpendicular to has slope -2/3. So the slope of the line perpendicular to it, there's my perpendicular symbol again, would be the negative reciprocal of this one. Negative means negative, so negative of a negative becomes positive. Reciprocal means to flip. So the slope of the line I'm looking for is not -2/3, it's +3/2. So again, if they're perpendicular, not only will they not have the same slope, they probably won't have the same y-intercept. They could. It's possible, but they might not. That's why I'm writing it y equals 3/2 x plus b to find out what this value is going to equal. That implies, for me, I must use the point that this equation representing the line I'm looking for contains this point 4, -1. The y value that I will use is -1 equals the slope I'm having to use is 3/2 times the x that went with -1, which is 4, and then plus b, which I'm looking for. Again, 2 divides 4 twice. 2 times 3 is 6. -1, -1 equals, multiplied out, that's 6 plus b. To get b, I now add -6 to both sides. -6 to both sides. -1 add -6 is -7. -6 add 6 is 0, and 0 plus b is b, so b is -7. So our line's equation, the one that's going to be perpendicular to the one that was given way up here, the one I was looking for, perpendicular to this one, has the equation y equals 3/2 x minus 7. These are the types of problems you should be working on this coming week, and I will see you in class next week.